Welcome to Module 5, Lesson 5.1. You'll find this on pages 141 through 146. The subject skill that you'll learn is percent of increase and decrease. There's a formula that they like to do in your book. You'll find it. Percent change, which is the amount of the change divided by the original amount. Percent increase describes how much a quantity increases in comparison to the original amount. You need that formula to do that every time. These are the notes. If you want to pause the page, and then I can read them to you, or you can listen to them read to you and then pause the page. It doesn't make a difference. So I need for you to put this in your notebook. Finding percent increase. The percent change is always going to be found by the amount of change divided by the original amount. In a while, you'll see that I abbreviate this formula because that's an awful lot to write out. The change might be an increase or the decrease. You have to think about the scenario. Are you increasing or decreasing? Because these will all be positive numbers that you're working with. The percent increase is going to describe how much a quantity increases over the original amount. The very first example they give you is on page 141. Amber got a raise and her hourly wage increased from $8 to $9.50. What is the percent increase? So I just wrote down the facts from the problem. I didn't write the whole thing out. Amber got a raise from $8 to $9.50. And they wanted to know, what is the percent increase? Well, obviously, you know it's going to be an increase because you're increasing from $8 to $9.50. So you know you're going to be working with positive numbers and you're looking for an increase. So that's why I'm saying you have to think about what's going on. This little symbol here is a triangle. This little symbol here means the word change. Instead of writing that out every time, you'll see that I use that symbol a lot. Step 1 is find the amount of change. I could have written it, find the amount of triangle, and that should have said the same thing, find the amount of change. So this is what I'm doing over here. $9.50 minus $8 gives me $1.50 change. She had a raise of $1.50. Step 2 is use the formula. Here's where the formula gets really condensed down because you don't want to write all those words every single time. I want to make sure you can see that really good. Okay, step 2 is use the formula, and you're going to round to the nearest percent. This is where the calculator comes in handy. Sometimes it's going to have a lot of decimal places after the decimal, and you just have to round it. Here's what the formula means again. Percent of change, okay, is going to be equal to the amount of change divided by the original amount. So as you can see, as I come down here, I start plugging in numbers. Percent of change equals, here's my $1.50 because that was my amount that changed, right? And I divide it by the $8. $8 is what she originally had. And then down here, it solves out onto the calculator as the percent of change equals 0 and 1,875 10,000s. But I need to go to percent. So I'm rounding it off to 2 decimal places after the decimal. And it's going to look like 18 is going to be my last digit. But I look at the 7 to see if it stays in 18 or rounds to a 19. And 7 makes it round to 19. So whenever I move my decimal place over to round this up to 19, the rest of it drops off. I add my percent symbol. And I use this new symbol here that we haven't used so far this year. And it's approximately. It's approximately. So turn your page. Now, reflection number 1 is going to be on page 141, and it says, what does a 100% increase mean? A 100% increase means the original amount would double. I mean, if you have 100% of an increase of $2, you're now going to have $4. You're going to try your turn on page 141, and then after that, then you're going to move on to the rest of the notes. The next section is on page 142. And now you're going to find a percent and a decrease, okay? David moved from a house that is 89 miles from his workplace to a house that's 51 miles from his workplace. So as you can see, it's going to be closer. So you're decreasing. What is the decrease in the distance from his home to his workplace? So once again, I just wrote down that finding the percent of decrease. This describes how much a quantity decreases in comparison to the original amount. And I just wrote down the very basics from the word problem. Example 2, David moved from 89 miles to 51 miles. What's the percent of decrease? Okay, so you don't have to write down the whole entire word problem, just write down the important facts. Once again, here's my formula. Amount of change, that's what the triangle means, the amount of change is always divided by the amount of change that happened divided by the original amount. So here I even shortened it down to A of triangle, and then I started plugging in numbers. He lived at 89 miles from his workplace, and then he moved from 51. So of course I'm going to subtract that. And then you're going to divide it by the original amount, which was 89 miles. The amount of change is 38. Whenever you subtract 89 from 51, I got 38 divided by 89. This is what I'm talking about when the calculator is going to give you a bunch of decimal places. So when you do 38 divided by 89, you're going to get 426966629, and the numbers just went on. Well, I need to round that off to a percent. So I'm going to count 2 decimal places right there, and it's either going to be 42 or 43. I look at the digit behind and notice it's a 6, so it's definitely going to be rounded to a 0.43 or 43% decrease. The reflection number 3. Reflection number 3 said David considered moving even closer to his workplace. He claims that if he done so, the percent of decrease would have been more than 100%. Is David correct? Explain your reasoning. David really has a warped sense of how this works here. David would only have a 100% decrease if he lived 0 miles from work. I mean, I don't know how it'd be less than 100%. I mean, you can't, I don't even think that's possible. Anyway, you're going to try your turn number 4 and number 5 on page 142, and then you're going to move on to the rest of the notes. So you can probably pause it here to do those 2 problems. Page 143, using percent of change, given an original amount and a percent increase or decrease, you can use the percent of change to find the new amount. The grizzly bear population in the Yellowstone Park in 1970 was about 270 bears. Over the next 35 years, it increased by 115%. What's the population in 2005? So once again, I just wrote down the bare essentials from, no pun intended, wrote down the bare essentials from the word problem. We're at Yellowstone Park, 1970, there was 270 bears. Add 35 years, because they had 35 years for the next 35 years. That population increased by 115%. So in 2005, they want to know what is the population. Okay, so step 1. Step 1 is you're going to find the amount of change. Remember, the triangle means change. Find the amount of change. So I'm going to find 115% of 270. Okay, so I'm going to first change 115% to a decimal before I multiply. See how this triangle can be used for the word change all the time. So I have 1 decimal 1 5. That's removing the percent symbol and putting the decimal back where it belongs. So 1 decimal 1 5 times 270. Now I get 310.5. Okay, I can't have half of a bear. That's going to be a little bit messy. So I round this up to approximately 311. So that's what my bear's increase was. Step 2 is I have to find the new amount. I found my increase. Now I have to add it to the original amount. So here's the formula for that. My new amount will consist of the original amount plus the amount of change, which was an increase. So I plug in my 270, that was my original amount, My amount of change was 311. So now in 2005, I have 581 bears in 2005. Reflect number 6 says, why will the percent of change always be represented by a positive number? Well, it's always going to be represented by a positive numbers because you're always counting the distance between the two values. Like back here, started out at 89 and you're counting the distance between 89 miles to work and then 51 miles to work. You're counting what was that distance that you don't have to do anymore. So you're always counting the distance. And when you're counting a distance, it's just like absolute value. Your value is always going to be positive. Reflection number 7. If an amount of $100 in a savings account increases by 10%, then increases by 10% again, is it the same as increasing by 20%? The answer to that would be no. And we're going to get into that in another module. I think it's 5.3, a little bit more. But the answer to that is no, because the original amount was increased by 10%. The changes between increases will be different. When you have your first original amount of $100 and you increase it by 10%, that gives you $110. Then that amount increases by another 10%. So you're looking at two different starting points for the original amounts. So again, the answer to that is no, because the original amount changes between the increases. And again, there's my symbol of a triangle. And I just put an apostrophe S there to brief things down. And this B/C stands for because. No, because the original amount changes between increases. You're going to try your turn number 8 and your turn number 9 on page 143. Once you finish that, please complete the guided practice number 1 through 21 on page 144. Enter all of your answers in TeacherMate. You'll find all of that on Canvas. Thank you.